All right, so you want to talk about the final. All right, everybody see this? So final exam, it's going to be the usual 10 questions. Short answer, programming, that kind of, say essay. So no true false, no multiple choice, just tell me what you know. And as usual, I grade my exams based on competence. If you write me some code and it has, a couple of bugs in it, I'm missing semicolon here and there, I'm not going to knock you points. If I look at it and say, this person pretty much knows what's going on, you're going to probably get all the points. If this person probably doesn't know what's going on, you're not going to get any of the points. Every now and then you got somebody who sort of knows what's going on, and that's when you get some points in the middle. But I'm not sitting there looking for tiny little bugs. I want to see overall, or how are you solving the problem? That kind of stuff. Remember, there will be at least one conversion question. So this is either base to base or call data size to data size. So for example, I might say, how many megabytes is some number of gigabits, that type of thing. I say at least one. Sometimes they'll do one of each of those. It just depends on the other questions I ask, but there will be at least one of those. Okay, so the exam, I don't know, when's the official time for our exam? Does anybody know? Wednesday, 10/10. Well, the official time is just going to be when I will promise that I'll be available, like on Slack, if you have questions or something like that, if you choose to take it at the normal time for the class. I'm going to put it up no later than Monday morning. It'll probably be up Sunday night. And you just have to take it sometime before midnight Friday. But you got to do it in one sitting, the whole rigmarole. Okay, so you can decide when it works best in your schedule, and don't work in groups and the whole rigmarole. Don't use ChatGPT. I encourage you, though, to check out ChatGPT for coding stuff, for leveraging it, because it really is a cool tool that you can use to augment your own programming for non-academic purposes, right? But sometimes you might say, look, I can spend a half hour writing this. I know I can do it. Why don't I just ask the AI to write the script for me real quick? Now I have it and I can move on and focus on the more difficult stuff or something like that. Really cool tool for that. So we said Wednesday at 10:10. Is that the time? Wednesday, 10 a.m. to noon is official time. I will be live on Slack for real-time questions. I don't anticipate that you'll have to ask questions. I think the exam will be fairly self-explanatory, but if that makes you feel more comfortable, I'll be there during that during that time. Otherwise, like I said, it'll be up Sunday night, just on Blackboard. Just take it sometime during the week before midnight Friday. You have 2 hours to take it. I'll design it to be about a 1 hour test. So there shouldn't be a time problem for it, but whatever. Okay, so let's go through. And I'm going to start at the beginning of the slides. I'm going to tell you, as I'm going through here, what things I think are important that you definitely need to know about, that you should focus on, and what things are more fluff that I wouldn't spend too much time on, because this is, programming is something you just keep building up. Obviously, you're probably going to have to write for loops and if statements and things like that on the exam. I'm not so much testing you on, can you write a for loop? At this point, you probably should be able to write a for loop. So if that's a major challenge for you, then you're going to want to really panic. All right, so definitely be able to work with strings, and pick your language in Java or C#. Really, for any of the questions on the exam, you can answer them in either of those languages. I'm fine with them. They're really the same language, so it doesn't matter. You know, I'm not going to take off points if you used a capital S instead of a lowercase s for string on the exam, but don't make up functions. Like, you know, blah, 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 dot, answer to question 3, open, close curly braces. Done. All right, so yeah, if you don't know about it, it probably doesn't exist. So answer all the questions in terms of the tools that you have available. Most of the time when I'm asking questions, I'm really asking you to show me how you problem solve. How do you think through the problem and give me some code that is a representation of that solution? I really care little about perfectly written code. Because when you type it in and you compile it a couple times and it screams about I'm missing this or I'm missing that, you're going to be able to fix it up. But I'm really looking for, have you written something mostly competent? And with a little bit of debugging with a compiler involved, is it going to work out? With that being said, I do not expect you to test your code for the exam. If you want to use an editor or something like that, so it's nicely formatted and things like that, that's fine. But I don't want you to run it so you can sit there and debug it to give me perfect code when all is said and done, because then I'm not really testing you. At that point, you know, you might have gotten it from someplace else or whatever. Show me what you're capable of doing as a first pass, and I won't knock you for little stupid mistakes and things like that. Okay, so I tend to like when I ask like programming questions, I tend to like string manipulation questions. I tend to like manipulating collections, like taking an array, do something to it, that kind of stuff. Things that are more like puzzly type questions play better on an exam. You know, I probably am not going to ask you to write a script that follows a rigid body or something like that on the exam, where, you know, even though that uses a lot of the stuff that we've done in context during an exam period of time, it's kind of hard to pull that off, let's say. You know, I'm not expecting you to, what's this? You can. I mean, if you want to write C# code in the context of Unity, I'm fine. I just don't know how well it's going to play and you're on the exam in terms of helping you. I think I tested that in the first exam, the string constants versus whatever. Big focus on the exam is definitely going to be object orientedness, inheritance, just that idea of public, private, protected. Understanding, you know, when do you make fields private? When do you make them protected? How does inheritance work? The this keyword, the super keyword, be comfortable. I would be very, very, very surprised if there isn't at least one question on there. I think we had one on the midterm. Like, here's some scenario, create a class called player that has fields for representing the name, the hit points, the armor class, or, you know, the first name, the last name, the jersey number, whatever it is, has a constructor and the appropriate getters or something like that. You know, show me that you can create a blueprint for an object to start writing some logic with. I won't ask you questions specific about like our implementation of Dungeon Crawler. Like, how did we accomplish X, Y, Z, you know, a month and a half ago, you know, inside of our Dungeon Crawler? Why did we write this stupid line of code? That kind of stuff. So there won't be, you don't have to go back and make sure you understand exactly how we did every little thing, but you should understand the underlying things that we did and be able to create your own stuff. Definitely be able to work with threads. We're going to bump into that soon. So understand the concept of threads, understand the what they're used for. It would be fair game for me to ask you to write a class similar to like a worker bee in Java, where I say create a class that extends thread and create the public void run method that accomplishes something. Remember, when you tell a thread to start, it automatically calls the run method. So that would be fair game. And remember, our kind of our version of threads that we have control over on Unity is our coroutines. I probably won't have you writing something specific coroutine-y, but really mentally you can just think of coroutines and threads as duplicates of each other. They're running in their own, thread of execution, and they finish when they finish. Yeah.
So just say like to make a thread.
You can use either. I don't care. I would think that the Java code for a thread would be a little cleaner than doing the whole IEnumerator thing, whatever. But at the end of the day, I don't necessarily care, as long as you're really showing me logic that is written in such a way that it assumes that this is running in its own non-blocking thread of execution, and this is the logic that I would use as part of that. You could probably ignore things like whether or not certain things become problematic in Unity, like some while loops cause it to run out of, lock up thread space, things like that. You don't have to worry about that during an exam. I'm looking for your ability to kind of wield threads in problem solving, regardless of how you want to accomplish the thread. Definitely no static versus non-static. I would say it's quite probable that I might show you some documentation for a function and tell you to use that function to solve some problem. You'll have to show me how to call it, even if you've never. What I'll probably do is I'll probably make up the function. It'll be some invented function that doesn't actually exist, but it'll have all the right things in it that will tell you how you would call it and ask you to solve some problem with it. So you'd have to show me that you know how to call either a static or a non-static function. Similarly, if I ask you to write a static or a non-static function, you should be able to do that as well. I would think there would be a better chance of me showing you documentation and asking you to be able to read it and use it than asking you to write static versus non-static. That's just putting word static in front of it or not. Really, the skill I want to test is, can you read documentation and put things to work that you haven't necessarily learned before, but you can now leverage because you know how to read documentation. Like I said, public, private, protected, kind of know about those things, when to use them. When it comes to methods and fields, really in the context of inheritance is probably going to be the larger focus, but really for anything object-oriented. Definitely understand this hierarchy idea of object-oriented programming, that all of our object-oriented languages have this top level object class. It's a lowercase o in C#, it's an uppercase o in Java, and all of our classes kind of come from that guy. Understand what an abstract class is. I'm not sure I'll have room to ask a question about it, but it would be fair game. Remember, that's a class that's built specifically for inheritance. You never like our inhabitant class, right? We never actually are going to create instances of inhabitants, but players and monsters are built in terms of inhabitants. Definitely know about the super keyword. The concept in object-oriented programming of being able to access the parent. All right, that's the super keyword. Whereas this keyword is the concept in object-oriented programming of how do we access the instance of us. Okay, whether it's this or self or whatever. Go ahead. I think the equivalent was base when we were calling the constructor. I think the super keyword still exists in C#. It just that's not how the call your parents constructor syntax worked. I'm not sure why that was that, but it's a little bit funky in Java too, where you can use super to call a parent's function. You could say super dot do something. But if you're calling the constructor your parents, it's super open parenthesis, the parameters, and it has to be the first thing in the function. So there's special rules attached to it in Java too. So with that in mind, since it has to be first, maybe it actually does make some sense that C# said, let's pull it out of the inside of the function, inside of the constructor, and put it next to it. You won't have to memorize that. You know, if you are on the exam, if you write some code that wants to call the parent's constructor first, and you just write me something on that very first line that kind of indicates, hey, I really want to call my parent's constructor first, I'll get what you're getting at. I'm not going to take off points if you have weird syntax for that whole base thing or whatever. Relatively unimportant. What I'm really testing there is your understanding of object-oriented programming and that concept of, oh, if I'm a child class, we have to build an instance of our parent first, and then we can differentiate ourselves. And we did that more recently in our game, where we put our hit points, armor class, and damage into inhabitant, because both monsters and players have those things. But then we made our players supercharged, right? We went into the player class, and after we had already created them with, you know, random armor class and random attack, we just went ahead and tweaked those numbers a little bit to make them basically invincible and hit really, really hard. So that's how we differentiated a player from a base inhabitant. All right. And that was for our testing purposes, so fights didn't last forever, and that we didn't have a coin flip as to who was going to win the fight when we were trying to test something. Okay. So definitely that super and that this keyword, these are core components to object-oriented programming, which I would say if you were going to pick a theme for the exam, it would be object-oriented programming. This concept of leveraging objects to solve problems. Won't ask about that. That's you probably won't have to use the instance of operator of the exam. Understand blocking versus non-blocking. We already talked about that. That's that whole idea of why do we need threads sometimes. That will be on the exam in some form, whether it's write a thread to do something, or here's a scenario, what would you do? I maybe wouldn't just ask what's the difference between blocking and non-blocking, but I could. So understand that concept. Probably wouldn't ask anything about interfaces. They're very, very, they're the, first cousin twice removed of inheritance. They have their place, but we didn't really work with them. And other than we saw them in the context of threads implement the runnable interface. And the runnable interface says you have to have a function called run. So an interface basically says, here's a set of things that you have to have if you choose to advertise that you implement this interface. I don't think I'd be able to come up with a decent question on an exam that would be able to test that. So let's see. We want to think about what kinds of questions we might ask Unity specific. It would probably be fair game for me to ask something about like transforms. So the idea of a game object, the idea of a transform, all game objects are at least a transform. A transform is a collection of position, rotation, and scale. And all those guys are vector threes. So probably know what a vector 3 is, know what a transform is, know what a game object is in terms of it's kind of like our top level object in there, similar to like our object in Java or C#. I won't ask things like, rigid bodies doing things with gravity or adding a force to something or things like that, things that are sometimes more experimental. You mess with it. So you won't have to write code like that, but there could be a question that uses that concept of game objects or vector threes or transforms. Similarly, definitely it'll be represented on the exam, that idea of MVC, the model view controller, where we have our data behind the scenes. That's where we had our instances of like dungeon and player and room. We brought over our Java implementation. So that was our model, keeping track of the current data that's kind of driving our game. Then the view, that's our interface that we, made look pretty. And then we have our controllers. These are the scripts that are driving the game objects that are, moving around on our, in our game, in our views. All right, so understand that concept of MVC, where it says it's a good idea to keep your data separate from your implementation or your interface, your logic separate from your view, your interface. That way things don't get too crowded together and difficult to manage. We already saw here towards the end of the semester that, we were starting to get a pretty good amount of code, right? We had a whole bunch of classes that were our models. Those were our Java stuff we converted to C#. Then we had all those mono behaviors. Those were our controllers, right? So all those were inside of Visual Studio as just code, and that was starting to get a little bit unwieldy, right? And then we had our two scenes, which was probably the easiest part of all of it, but we had to think about, well, how do I connect these two together? So that's that idea of MVC. Also, singleton will be represented one way or another on the exam. So that other design pattern we talked about, it's a good idea when you need to share things among multiple screen scenes, however you want to think about it, to put it all in one place that's easily accessible. That was our master data class that we wrote in our game, where we could keep stuff and share it as we, went through different scenes and have access to it. So there's that idea of a transform. I won't ask anything about rigid bodies. Design patterns, know what they are in general. I'm not sure I'll ask a specific question of what is a design pattern, but you should kind of know that they are an idea, not an implementation. So we looked at two different design patterns, MVC and singleton. And those two design patterns say it's a good idea to do something like this, but we are reliant on how did Unity implement model view controller, which they do it one way. Android Studio has their implementation of model view controller, which is similar-ish, but not identical. But they're both accomplishing the same thing. So understand that design patterns are a suggestion, not an implementation. All right. Here's the singleton. Huh? Yeah. Yeah, I said it. Yeah, so there's kind of our visual of our model view controller in our game. So the data was our old dungeon code that we wrote in Java. Unity controllers are the controllers. There might be a little bit of wiggle room between those two. And then our view is what we actually see on the screen. Okay. Questions about the exam? Oh, everybody's good? All right. So like I said, I'll have it up sometime, I'll promise it will be up by 8 a.m. on Monday, but there's a pretty good chance I'll have it up Sunday night. And you can take it at any point in time. Just make sure when you sit down to take it, give yourself 2 hours. I'm telling you, you have 2 hours to take it, but I'm going to design it to take 1 hour. Some of you may even finish it in 20 or 30 minutes. So it should not be a time constraint thing, but if you want to be able to take your time and really think through it, all that stuff, just set aside the time for yourself. Okay. If you're satisfied with your current, you do have to take it. Yeah, remember I have my policy only goes one direction. If you did crappy in the midterm, and you do well in the final, I'll replace your midterm exam grade with what you get in the final. But it doesn't go the other direction. Yeah, you can't get a 95 in the midterm, phone in the final, and just coast on that 95. You only get to make your midterm better if you do better on the final exam. You have to take the final exam.
So if you get out of the midterm, you have a chance to break it up. So if you do good on the midterm,
If you already took the midterm. So that grade is set in stone unless you do better on the final than you did on that exam. If you do better on the final, I'll replace what you earned on the midterm with the grade you had on the final exam. If you got a 50% in your midterm and a 90 on the final, now you have two 90s. Well, that's sink or swim. Yeah, if you got a 90 on the midterm and a 50 on the final, you have a 90 and a 50. Yeah, you don't get to fix your final exam with a good midterm, but you can fix a bad midterm with your final. Hey, most teachers wouldn't be that fair, would they? That's a pretty good deal. Well, I mean, and that could work in some classes. It just kind of depends on, for example, we're coming into this exam, regardless of what class I'm teaching, I can probably walk around the room and pick the 3 or 4 people who are probably going to write the answer key on an exam. So realistically, they're kind of going through the motions, but they have to take the exam just like anybody else. But maybe these people, have a background in this stuff, and eventually curriculum catches up with them, right? But at the end of the day, I think taking exams under some level of pressure, even though I try to take as much of the pressure off as possible, is actually a pretty good skill to have. I mean, how many people do you know that you know to be like really smart or something like that, but they say, oh, I'm a bad test taker, right? And it's not so much they're a bad test taker, is they don't perform well under pressure. And that's a skill you're going to have in real life. So, I think it's good for you. It's good for mostly good for your health to take the exam. Well, yeah, because now that's where procrastination meets caring about your grade, right? It's like, I'll wait till the night before, but I'll hit that deadline. It's not an option not to turn it in, but I might submit it at 4 a.m. Hey, I get it. Hey, look, you're all adults. You got to manage your time just like anybody else. You get to pick what's most important today. And then you decide what gets slid out of the way, whether it was good for your health or not. All right. So makes sense what the policy is related to the midterm? Okay. Well, so let's spend at least a couple minutes here at least talking through what I would have done for this particular assignment. So you get an idea on maybe doing things like this in the future. At least from my perspective, this is how I would approach it, which isn't necessarily the perfect way of approaching it. But what I would probably do is I would probably create another scene. All right, let's start off with finding scene. Remember, I have bad eyes. Help. Yeah. Oh, is it not up here? Right below. Oh, that's super helpful. I wasn't joking. Actually, I finally saw it. It has to hit that. There's a very perfect line where it's got to get clarity there. Well, I wear contacts for VR, and I wear trifocals by prescription, so I can't see any of this. So I might just create a scene just called like playground or something like that. Because what I want to do is I want to kind of have a scene where I can go in and I can just design my my setup here for my whatever, attach all the scripts to it, things like that, and then ultimately I want to pull it out as a prefab. right? And once I have it as a prefab, I can drop that health bar on anything I want. Might have to hook a couple of things up, something like that. But this kind of gives you maybe an idea if you're working on a larger game. You maybe have a single scene like this, where it's kind of like your workshop, right? Where you can kind of, it's not really part of your normal logic of the game. You don't have to worry about breaking, something. You don't have to, especially if you're working on it and you have to say, well, how should it work in my game? You still can go back and run the normal game and, see how you want it shaped or whatever, and then just go back to your playground scene and mess with that. Yeah. So it's your workshop where you can kind of mess with stuff until you get it working. And then also it's a place where you can come back and tweak it. And when you save it, it'll update the prefab, which will update all uses of the prefab. Right. So you never actually have to go and fix your health bar in 20 extra places. So I would go into here. Now you can decide how you want this to be. I'm just going to kind of quickly start slapping something together just for the sake of time. So I'll create a, we're going to do it this way. So I'm going to create a cube. And actually, it's this way, right? Oh, wait, no, it's not that. It's the Z. Perfect. All right. So I have two small cubes like that. And what I'm going to do is I'm going to create an empty game object here. And we're going to call this guy health bar. And we'll just drop those two cubes inside of health bar. Well, or let's try to do it more better. There we go. Most bestest. Perfect. All right. Now we want to actually have like the little health bar, cubey, flippy dealy, whatever's. All right. So I'm going to start, and here, let's just call this outer block. Actually, here, we'll call this guy bottom and top. All right. Now what we want to do is we want to go ahead and we're going to create another 3D object. We're going to create a cube. And we're going to toss this guy in here. And let's see how many of these. I probably want to get 10 next to each other. Is this going to, oh, Ninja. All right, it's perfect. And it's to scale. Dun, 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 dun. All right, so I got those guys, and then we will make these guys just, where's my, this one, scale. All right, perfect. And then we'll hug this a little bit. Oh man, that's going to be so good. All right. Now, maybe what we do is we go ahead and here, I'm going to create a empty dude there. We're going to call these guys percent blocks. And we put those guys in there. We could probably name them better if we wanted, but we're not going to. So, all right. So now what I'm going to do is we're going to want to make them a color. Can we do that directly or do I need a material? Let's make a material. already have a material? Ooh, well, let's make it different. So we're going to create a new material. Is that, it should be red? All right. Red for the health bar. And click on this. Dun, dun, dun. So good. All right, then we'll highlight those dudes. We will, oh, I know. Oh, that's right. Ha ha. All right. So there's my health bar for this dude. All right. Now what we want to be able to do is we want these guys to be able to, disappear on some sort of, I think we had needs to grow back every 3 seconds or something like that. We also want to have a way for it to kind of go down. So we're going to mess with that a little bit here. So we're going to go ahead and we're going to create a script. And let's call this guy health bar controller. Call that good enough. All right. And we're going to go ahead and click on our health bar here. And we'll add a component, health bar controller. And we'll go ahead and open that guy up. So what we want to have is we want to have our game objects. So again, we're using MVC here. We want to know the various blocks, right, that we can make appear, disappear. So we need to make sure we keep them organized. So we'll say public game object. Maybe we call this guy health 10, health 20.
Do an array, and then you just define the size.
You could, you can actually put an array in there, and then you can work with, yeah, let's go and look at that. We could do a game object array. Call this guy the health. What we want to do, the health boxes. All right. And we're gonna have 10. Killing me. We're gonna have 10 of those. All right. So by doing that, now we'll see that we get kind of a collection of drop things in here. We do need to be careful how we drag it in. So when I go back over here, and if you didn't do it this way, it's okay. When I click on my health bar, here's my health boxes. Notice it has 10 drop-in things for me now. All right. So I probably want this to be bucket 0, bucket 1, bucket 2, so on and so forth. So I think, let's just make sure my assumption is correct here. Yep. Okay. And you probably could have programmatically figured this out too if you really wanted to, but I missed. All right, so now I have those guys in there. Let's just test this real quick. So inside of start, if I run this right now, we'll see all of them are there. Oh, actually, hold on. I need to adjust my camera. So here's my camera. Oh. Let's go there. Have it looking straight down. And then we'll just maneuver right above it. All right. So now we should see our health bar. All right. Now we could have always maybe make those cubes a little flatter if we wanted to, but now we have some depth. So, in case we want to go 4K, bring this into VR maybe. Wow. All right. By the way, turning our thing into VR would actually not be overly difficult. All you do is replace the camera in here. You probably would bring either Open VR or Steam VR plugin, and then you can replace the camera with something called the camera rig. And the camera rig automatically processes the HMD, the hand controllers, the whole rigmarole just built into it. So just replace your camera with that, probably hang the camera onto our player. And now you're looking through the eyes of the player. Just make sure you position that the thing at the height that you want the player to be. Now you got a VR-based dungeon crawler. And you probably get to get pretty nauseous during a victory jump. It's like, yeah, see, that's where you get power with some of this programming stuff without doing very much. You can just use gravity, and you can get one of the prefab cave things, where it's just like a big long tube and things like that, where you could bounce off walls and things like that. Turn it vertical have the VR thing, the camera rig facing the thing, and literally drop them in like Plinko. Just like gravity to work. You don't have to write any code. You're just wearing VR and you're falling through a chasm and bumping into walls and stuff. You'll be sick when you're done. Right? That's 10 minutes of coding. 99 cents on the Oculus App Store. How long can you make it? Before you have to rip the headset off. we might be onto something here, actually. It becomes like this big it takes off. It's all over TikTok and stuff with people like, he's been in there 25 minutes. I don't even understand. And we have to use the eye tracking to make sure they keep their eyes open. Yeah, no closing your eyes on this one, kid. All right. So just to kind of show that we have this thing off, I'm going to go ahead and say this dot, the health boxes at bucket. Remember, its size would be 10. So legal buckets are 0 to 9. So I'll say 9 dot set active to false. And we'll do that to 8 too. So we'll give them 80% health here just real quick. Oh, ninja. And now we should have 80% health. And then if we put a thread on this guy and had it every 3 seconds, start turning them back on. Now you have a health bar is what you got. All right, make some sense? Oh, so what I would do is I would come into assets here. There I have a folder for prefabs. I'll just create a folder for prefabs. Oh, sorry. And I'm going to drag that health bar down here. Yep, that's it. So scripts, all of it's on it. So now if I go back to my my normal scene, I can go ahead and get rid of that guy. Oh, actually, why don't we just put that guy in there. We'll rotate him on Z, right? Oh, Three-dimensional space is not my oh, nailed it. All right, then maybe scale this dude down a little bit. That's going to be dun, 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 dun. All right. We'll just get rid of that guy. Delete. And we'll take this guy. That's our health bar. We'll attach it to our player. Then we'll position him relative to our player. And there's our 80% health. Oh, the player drops down. Yeah. Oh, actually, we have it upside down though. They are missing. There's two gone here, but they're on the bottom. So we might have to do a little maneuvering, but you get the point. All right. And if we go back and change our prefab and save it, it'll automatically change on this scene. All right. Questions, comments, concerns, bribes. All right. I'll push the final version of this code just so you have it all. Otherwise, I will see you when I see you. Yeah. Oh, and remember 12:30. So here in a half hour, we have a potential faculty member who's interviewing. They're going to be on Zoom, my Zoom channel for my class. If you want to jump on there, even if you can only stay for 10 or 15 minutes, so he has an audience, pay attention. And if you want to send me feedback, if you think they would be good in the department, sucky in the department, whatever, please feel free. So that's in 30 minutes. Yeah.
First one was the Bible converting was due tonight.
Yes, say officially, but you can turn it in by the end of finals week. Okay. I'm fine with that. Yeah.
The second question, really quick. Do you know, because we talked about this before the classes, if they ever going to bring back like animation classes again? Because I remember.
Well, we still have animation 1 and animation 2. Those still exist. Yeah, the only class we've gotten rid of is animation 3 because it never fills. It's always, I mean, the class still exists, but we don't put it on the schedule.
Okay, so these still have animation.
Oh yeah, those are always scheduled.
Okay. Just wanted to make sure.
Yep.
I really wanted to take.
Well, let me get